How do you make an API with AppSync? Well, that depends on your requirements. Are you making a personal blog or the next dating website? Wait, dating websites are pretty simple. I guess that's why you still don't have a girlfriend. An API that I created for a customer has strict authentication requirements, and I wish I had some kind of guide when I started creating that API. So let me enlighten you with my experiences. In AppSync, when your request first hits the server, it will be validated against our API schema. The schema is the one that you see here. That helps us to ensure that the client sent us the data that we want it to send us. After validation, the request is sent to a resolver. First, a mapping template decides how this request will be sent forward. For example, here we have the create game mutation, and we would have a resolver for that. And here's the mapping template saying what we do with the request. And here's the data source where the request will be sent after the mapping template handles it. 3 major ways of handling requests in AppSync. 1. Mapping template. 2. Using purely Lambda logic. Or thirdly, we could use the mapping template to form the request and then use our own created generic Lambda that might have more functionality than just using a plain mapping template that goes straight to the DynamoDB or such data source. Mapping template. This is clearly the approach that AWS has created AppSync work really well with. So you might just get a very basic functionality with this one. In a mapping template, we have the 3 steps. We have the schema, where we could, for example, require that name is defined for a game, and we could optionally require publisher, like so. The mapping template, which allows you to make conditions, pretty clumsily maybe, but for example, you could define that the name of the game has to be from 5 to 50 characters long, and you could make some basic identity checks. For example, that the user is an author in the site and they have the author role, which allows them to add new games. Thirdly, we have DynamoDB conditions. With this one, you could, for example, check that for a single year and title, we have only one game in our database, if you wanted to. In a typical website, you would get actually pretty far with this. That's because in AppSync, we want the client to really handle all the state of the application. We want the client to be able to be aware of all the data changes so that it can work fully offline, and the server should just make the simple changes that happen per client's request. But the biggest problem in this is that we can't, of course, trust the client in security issues. And if we need to do some security checks for authentication, for example, then we need the server-side logic for that. AppSync documentation will tell you that you can do security checks by identity claims, but these are really good for only that high level, like role-based authentication, for example, granting someone the author so they can post games in our site. But if you really need some fine-grained control, like this user can post this game and allow that other user to edit it and other group of people to see the game that they posted, then you need to make database queries for that. If you really want another example, you could maybe want to save edit history before making that game so that you for sure have the knowledge that this user made or modified the game at this point in time, and you can go back in history to see that. You could implement that with DynamoDB streams if you want to do it after creating the game. But streams are only good sometimes. For example, you cannot use them to make the history marking before creating the game. Remember that if you have just a couple of API methods that are more complicated, you could just back those ones with Lambda. We're really just looking for the best maintainability. That's something where you need to balance things. Those couple exceptions are probably not gonna break your maintainability one. We just want the best possible maintainability for majority of our use cases. If you want the basic introduction and be more comfortable writing schema and resolvers, check out the first video. Now we're gonna see more in depth how they work. Previously I showed you this great game. Let's see more about how this resolver could be implemented. Here is the great game resolver. I've made some changes to it. Let's see. So the ID is the key. It's taken from the arguments that the client sends us. And we also save the creation moment. We could also save, this is usually good hygiene, updated at and created at, that we save. And then we always have some kind of timestamps. We set now to the time with this utility function. We save it as a string, ISO 8601 string to the database. Then we take all arguments from client except ID, and we iterate over them and send them to the database. Save. I have emptied the database. This is a mutation, as you remember, and we can run ID0, name my game, send it. Alright, we need a comma here. One thing I hate about this mapping templates is I always get them wrong the first time, always. Okay, we insert this my game. It's inserted. It's in the database. Right here. One funny thing I noticed today, there is a big problem with this way of doing things, which is I hope I got it right. Do you see this? Let's make another game. Let's call this the innocent game. And what is this we got? this into database, but it only returns this as the name. That's because we just executed mapping template injection. We got this data injected here. Now we have mapping template injections. I think you should be able to do this with AppSync mapping templates, but you actually can't without exposing yourself for injections. At least with this one, we should be able to avoid this vulnerability. Now I just made it like this. I don't know, leave me alone. Now when it's executed, it properly escapes the injection. I think everything given to this mapping template should already be mapping template escaped, so if you print the input to this mapping template, you wouldn't be vulnerable to mapping template injections. If I have any great news to this kind of things, check down below. I'll post it in description or the comments. Secondly, Lambda data sources. Create a function. Game creator Lambda has access to log things. We'll add it as a data source. New mutation, Lambda create game, which creates game with Lambda. And we'll just forward everything to this Lambda. Here we'll just console log event as such. Instead of create game, Lambda create game null. Why? Because this Lambda doesn't really return anything, but it does log, and it did log event that it got, and it got these things that we send it. You don't have to have the wildest imagination to see that instead of logging this event, we could save it to the database.
Our second method of creating an API with AppSync is Lambda logic.
When your API methods will be too complicated to just perform a single DynamoDB request with them, this is what first comes to mind. Instead of using mapping templates and saving data to database by mapping templates, you just pass your data to a Lambda and you handle it like in any normal backend server you would. You could have a single Lambda for handling everything. You could have a separate Lambda for each API method or some kind of grouping of Lambdas. Running a Lambda, of course, costs more time and money than just making a single request from your mapping template, but that's what you have to pay when you have to execute more complicated logic.
No way around that.
Let me show you how this may look more clearly. I made you an example, re-adding some less hostile data now. ID2, name, innocent, game for reals, using this Lambda create game. It ended up in the database, and it looks like this very naive and short example of how this would work. Thirdly, we could mix the mapping templates and Lambda together so that we construct what we need in the mapping template, and then we give that to a Lambda, and that Lambda could be more generic. This way we could have a code base that we don't need to change, and when we add API methods or change them, we just change these mapping templates. And of course, you can easily mix and match whatever you want. You don't have to use DynamoDB at all. You could use relational databases with lambdas. Let's just edit this lambda that we have. A mutation, lambda create game. The mapping template could be something like this in payload. Instead of just dumping everything to the lambda, we define operation is put item, table is game, query has these arguments, it has ID, created at, updated at, and all the other stuff. And the lambda reads operation is put item, so it runs put, defines the table and the query here. We run it, and it comes to the database with created at and updated at. Obviously, you could extend this in any way, defining the mapping template what you want and then handle them how you want here. And now the game creator is a bit bad. This could just be like AppSync or GraphQL handler, or you could just not use mapping templates, whatever you want to do. This is if else branch telling you to put your mind into it. You can use lambdas. Possibilities are endless. You could even code it with Go if you want to, or Python too. Then how is AppSync different from the other GraphQL backend solutions? Well, it's included in AWS, so you don't need to go shopping from different vendors. And if you have all your stuff already in AWS, you can just assume that if AWS goes down, you go down with the ship, and you don't have to also be in other ships simultaneously that could go down. Hooray, vendor locking!